Pitless drilling technology from SmartiteTM Energy Solutions. Greenhouse gas emissions comparison, pitless versus pits. How big is your carbon footprint? We're going to start with going over a short agenda. We're going to talk about the impact of plastic liners, greenhouse gas emissions from fossil fuels, what the impact is of pitless drilling, greenhouse gas emissions from pitless drilling, and then I'll end with the comparison summary. So what is the impact of plastic liners? Plastic that is unmanaged ends up in the environment, where it continues to have climate impact as it degrades. Plastic liners have a shelf life of 1,000 years. Every piece of plastic begins as a fossil fuel, and greenhouse gas emissions are emitted at each stage of the plastic life cycle. Fossil fuel extraction and transport, plastic refining and manufacture, managing plastic waste, and plastic's ongoing impact once it reaches our landfills. Landfilling emits the least amount of greenhouse gas on an absolute level, but it presents other long-term and significant environmental risks and concerns. When plastic decomposes, it releases a potential toxic bisphenol A or BPA and PS oligomer, causing additional pollution. And these toxins are linked to reproductive issues. This is from Dr. Saito at the College of Pharmacy in Nihon University in Japan. And greenhouse gases, both methane and ethylene, are known to emit from the most commonly used plastics. Their emissions are initiated from exposure to solar radiation. However, once initiated, the off-gassing continues even in the dark. And again, this is a study that was prepared by Dr. Sarah Jeanne Roy. Carbon dioxide from fossil fuels. Diesel engines emit less CO2 and greenhouse gases than petrol engines. And this happens because of the particular type of fuel and the internal efficiency of a diesel engine. More specifically, the fuel used in diesel engines has higher compression ratio than petrol, and it therefore performs better than petrol engines. The four main pollutants that emit from a diesel engine are carbon monoxide, CO, hydrocarbons, particulate matter, and nitrogen oxides. And here's a graph that shows the relative breakdown of everything that comes out of a petrol or diesel engine. Diesel engines produce about 2.7 kilograms of CO2 for every liter of diesel fuel. Now let's have a look at pitless drilling's carbon footprint. During our trial, we had a maximum of 18 loads. No additional trucks were required to mobilize the equipment, so we only utilized the assets that were already on location. A long-term contract would reduce the total number of loads between 12 and 14. Fuel consumption during operations ran about 300 liters per day, and water consumption with pitless was reduced to plus or minus 400 cubic meters. So number of days on location, typical well, 22 days from spud to rig release. Transportation to the site, assuming the 14 loads at 5 gallons per hour, working 12 hours per day, times the 2.7 kilograms per liter, is about 8,000 kilograms of CO2. Now I have to point out that the trucks don't work 12 hours a day on moving pitless equipment. Now fuel consumption at 300 liters times the 2.7 kilograms per liter for a full 22 days is a total of 17,800. And then the water, to generate the water, the pumping of the water and so forth, would generate another 120 kilograms. So the total carbon footprint from a pitless drilling operation, around 26,000 kilograms of CO2 generated. Now looking at the greenhouse gases from a pit-based drilling operation, pit construction and excavation, about 3 days, working 12-hour shifts, 36 hours. Cleanup is estimated to be similar, again, a total of 36 hours. Fuel consumption, again, estimating at 5 gallons an hour for 72 hours of operation. And this is conservative because the construction equipment burns considerably higher gallon per hour ratio than with the trucks. There's no carbon footprint associated allowance used for the source wells or master pit construction or cleanup, so we're not making any allowance for that in this discussion. and the water used during pits is around 3,000 cubic meters. Plastic liner is 6 mil, and I believe this is incorrect as well. I think that most liners in pit drilling applications are between 10 and 12 mil, so we'll be able to, for future, you can double the numbers derived from the pit, or from the liner. Plastic generates a carbon footprint between 1.6 and 3.5, and so we use 2.7 kilograms per kg in this example. Life cycle of 1,000 years, continuing to emit greenhouse gases until decayed at a rate of 0.26 kilograms per kilogram of plastic. So let's look at it. The evaporation and excavation and cleanup, generating 3,450 kilograms of CO2. The water usage, 3,000 cubic meters, generating around 900 kilograms. Now the plastic liner kicks in, and during the fabrication and installation process, about 1,170. And here's the big one. Over that 1,000-year legacy of decay, you generate another 117,000 kilograms of CO2. Total carbon footprint of the pits, 122,500 kilograms of CO2. So when we come into a comparison of summary, you have your days on location are the same. Equipment loads are 14 to 18 with pitless. Fuel consumption between 8,000 and 10,000 liters. Fuel consumption with a generator, 300, about 17,000 liters. Fuel consumption for pit excavation and cleanup, 3,400. Water consumption, 119 versus 894. Plastic liner, we don't have one, they do. Plastic liner legacy, we don't, they do. So a total of roughly 26,000 with pitless versus 122,000 with pits. So we have a greenhouse gas reduction with pitless technology ranging between 80 and 90%. So we go from this on the left with 2,500 cubic meters of water, substantial carbon footprint, ongoing liabilities, environmental liabilities, and safety issues through the picture on the left. Just envision that pit is not there, no liner in the ground whatsoever, and no long-term side effects. So we save the environment, we have dollars saved, we have water savings, we have an environmental legacy reduced to zero, and safety improved by 100%. Greenhouse gas emission reduction, 80 to 90% with pitless technology. It's time to drill smart. Sure.